Hello, ಎಲ್ಲ ಹೇಗಿದ್ದೀರಪ್ಪ? I hope all are doing good. So today I'm going to take the session related to the IAL AS level computer science. The subject code is 9618. What is the topic I'm going to take today is the related to the assembly. So in the class, I almost I have finished up to the fetch and decode cycle. Now, according to your board paper, board exam, so assembly language related 4 marks questions they may ask, right? So that topic I'm going to record the session that will be useful. You can see the video, and if you have any doubts, you can send that doubts in the Gmail or in the comments. Okay. Now, I'm going to share the screen. So first, I will go to her syllabus copy. So I prepared all the things step by step. It is not an difficult, but you have to. So these are all the portion in the assembly that one already finished in the classroom. Assembly language, right? So data movement, input output data, arithmetic operator, unconditional, and compare the instruction, fetch and decode. Everything I have discussed. USB, these are theory topics. Now I'm going to deal with the problems. So these are all the instruction set. So you can expect this type of questions, the board exam. So what are the first? We have op code followed by the operand. So what are the op codes? That is LDM. LDM here we have data movement, we have input data, and the arithmetic operator, unconditional, and compare, right? So including we have the immediate, direct, indirect, indexed, and relative. That one we have discussed here. LDM stand for load, M stand for immediate. Instead of I is taken M. So slash n. As we know, there will be before I'm going to discuss all this instruction. So here slash stand for the binary. Binary means decimal number, and the B stand for binary number or zero ones, and ampersand that is stands for hexadecimal. But you must know that slash stand for binary. Okay, first you see all the questions. We'll assume there is only general purpose accumulator that I will tell. Yeah, ACC stand for accumulator, and this one denominates the index IX, index register that we'll discuss. And address can be either absolute or symbolic address that I will discuss with the problem. Then it will be understood. Here the slash stand for not slash. What is this? Hash stand for binary decimal, and the B stand for binary. Okay, now M slash n value directly immediate address, load the number n into the accumulator. So whatever the value in the number that you can store in the accumulator, that is LDM, immediate. You are not going to change anything. You know, if I'm going to tell this in the theory, you'll not understand. In the program, you'll understand the problem. Okay, LDD, that is here. It is LDD. That here, what is the operand? That address you are going to. So LDD stand for load direct. Direct addressing. Load the content of the location at the given address. Here in the immediate, what is the number that you are passing to the accumulator? Here, what is the content inside the that location that you are going to store in the accumulator? So what is the next one? LDI. That address indirect, I stand for indirect addressing. The address to be used to given address, load the content of the second address. If he has given LDI R1 dash R1 comma R2, you are not going to store the R1 value, R2 the second address you are going to store. And LDX, X stand for indexed addressing, I stand for indirect addressing, and X stand for indexed addressing. From this address, You are going to address plus the content of the index register. So index register means ix, that value copy, calculate the address to the accumulator. And the ldr, that is immediate addressing, load the number instead of here in the ldm, load the number into the accumulator, whereas in the ldr, load the number n into the index register. Okay, now move this and move the content to the accumulator, move the of the accumulator to ix index register. You see the app code and see the what is the definitions, and store the accumulator to the given address, add the values to the accumulator. Here what is the app values to your carrier address, and if he has given in the form of any number or else binary number or hexadecimal number, that you are going to add, and subtract if it is address, that you are going to subtract if it is given in the form of that one. And increment means you are going to increment the value by 1. If it is decrement the value by 1. And the another one is jump. This is very, very important. It will go to the jump to the address. It is it's like a loop, a jump statement. Then if it is true, it will go to the jump. And compare the address of accumulator with the content of address. We will use this one. And next one is compare hash. Compare the accumulator with the n value. Compare compare indirect addressing, that one value. JP. This is very, 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 very useful and very interesting. You see that JPE, it will jump if it is equal. If the condition is true, follow the compare instruction, jumps to the address. If the compare was true, what is that? If that is true, it is going to jump. And the second one is JPN, following compare instruction, jump if the address was false. If it is equal, E stand for equal, that will jump. N stand for not equal. If it is false also, it will equal. Next, in and out and end, that is okay. Now I'm going to see the question paper. So this is the question paper related question 8. The following table are part of set of processor. The processor has the accumulator and the index register. The theory we have discussed, right? Okay, what is that? LDM stand for immediate addressing, LDD direct addressing, indirect addressing. INC increment the value by 1, store the values, add the values, decrement, jump to the given address. CMP compare, and JP stand for jump if it is equal, if it is true, and end return the string. So okay, now I am going to the, so he has given the address 80, 81, 82, 83, and what are the instruction 10, 8, 10. These are the input. Okay, now these are all the values or instruction, opcode, append, that all he has given, and he will give the one table. Trace the program currently in the memory using the following trace table. So what are the input? I said 80, 81, 82, 83, and what are the values? 10, 8, 80, 81. These are the input. Now our instruction is, this is the accumulator and the instruction address, and I will parallelly open your key answer. So first start with 200. What is the instruction here? You want to try 200. 200. It is direct addressing, right? It is a LDD. It is a direct addressing. So what value is taking in the what is that? 81. In the 81, what is the value it is stored in? 8. So I can take 8 here. So instead of LDD, it is LDM. It is a immediate addressing means you have to take directly here 81. Here it is taking LDD. LDD stands for direct addressing. That value is stored in that. That value can take here 8. Okay. Now you will get the 8 here. Okay. Now in the second instruction is increment the accumulator. In the accumulator, what is the value it is stored here? 8. Increment means the next step. And what is the opcode here? 200 here, and next is 201. What is the value? It will become 9, right? Okay. Now store 83. That value, accumulator value, what is the value? What is the value it is stored in the accumulator 9? That you can store to 83. What is the 83? 83, it will join here, right? So that value is going to directly here. Got it? Okay. Now what is the next instruction? LDI. It is a indirect addressing. X stand for indexed. It is LDI 82, right? So now 203 is LD 82 83. Now your task is LDI stand for wait. Where is our instructions? Uh, LDI andre, so in the address used to be in the given address, load the content of the second address to the account. So now I have prepared the first instructions. So first is 8, next increment the value by 1, and the address 208 to the 9, that is okay. Now it is a indirect addressing, so we have to do the 2 steps. First, what is the value? It is stored in the value 82, that will be stored to the 80. Where is that? What is that? Is storing 82, right? Where is the value 82? In the 82, it is there 80 plus the now we can go to the now your task is 8. It will go to the indirect addressing 80. In the 80, what is the value it is stored? It is 10. That value you can add here. Now see the 10 value come to the accumulator. Don't confuse indirect. It is a indirect. It will jump to the not direct. 82 80 in the 82, what is the instruction? It is there, that value is going to join the accumulator. It will become 10. Now read the next instruction. JP. Now the question is what I said. JP jump it is equal. Now 209. What is the value stored here? Now it is 10, right? Now you are going to compare 10 with the 209. 209. Now the task is the accumulator value is 10, right? And it is going to increment the 209. The 209, where is that? JP jump if it is equal. Okay, now wait. 10. Now our task is to compare the accumulator with the memory address of 83. What is that? It is the what is there in the 83? Shit. I said mistake. Sorry. First it is LDI, right? Indirect address, it will become 10. Next it is compare. Now we are going to compare in the 83. In the 83, what is the value it is stored in the 83? It is 81, right? Now in the 83 value in store in 83 it is there 9, right? And in the 203 it is 10. Both are equal, not equal, right? Now our task is, now this one jump if it is equal to 209. If it is equal, you can jump to the 209 directly. It is not equal, right? So 9 is not equal to 10. It will not jump. So it will value, it will remain same. It will not see the instruction. See that 203 after 203, 204, it will not work. 205, it will not work. And next it is 206. Now it is storing. What is that? It is storing LDD 83. The 83 value, what is the 83? What is the updated value of 83? 9. Directly again, it will come to the Where it will come? 9 will come to the accumulator. Okay. Next, what is the next instruction? LDD add 10. 83 in the instruction, what is the 9 plus 10? It will become 19. Right. Next, jump to 10. And now the task is jump to 210. 210 means our task is directly 19. Jump to 20. Jump to 2010. 2010 means that value you are going to store to 81. What is the updated value of 19? That will jump to 81. That will become. And now you are going to skip the 209. That is not in. Sir, why you are not taken the decrement the accumulator? That is not required. What is saying? After that, you can jump directly to the 209. What is the updated value of that value is going to come here 209. So in the 210, it will jump. Now at the end, it is going to end. So here the main thing is if the instructions is immediate, you can take the immediate results. If it is LDD, you can tell what is the value that you can store. LDI, it is indirectly you can do, and if it is ulta, that you can do. And increment, decrement, jump equal. That's it. You have to, according to the instructions, we can change it. Got it? That is a formal question. And next is and bitwise and as we know both are one, it will one. In other condition 0. Bitwise XR, what XR says, if any one is one, it will work. If both are one, both are 0, 0. What R says, if any both are 0, it will 0. In other condition 1. LSL, logical shift left. LSR, logical shift right. That I can do in the next session. I will do this question number 1, 4 marks related. Another one question. We'll see. Another question. Now, okay. So now I take another question paper. This is 2000 computer science 1-3. We will do another one program. We can discuss. So here he is given instruction. Following table shows a part of an instruction set of a processor. Processor has the accumulator and index register. The LDM, immediate addressing, store, add the value, subtract the value, decrement the value, jump it is jump directly and compare with the value, jump it is equal. A stand for binary number, B stand for binary number, and ampersand for hexadecimal. So what are the 4 instructions you can see input? 50, 51, 52, 53. In the output, value is stored to 48, 42. You see 47, 48, 49, 50. Okay. Now, first LDM hash 50. Hash 50. What is the meaning of hash 50? So he has taken hash 50. Why is not taken this one? In the name only, he is passing, right? He is not taking the from 81 or 50, 51, 52, right? He is directly passing hash 50. So that value you can directly pass in the immediate addressing LDM 50, right? Not is not taking the 50th address. No, it is a in the last program that is a LD, right? Okay. Now it's taken 50. Okay, in the accumulator. So what is the next one? Decrement the accumulator. 40, 50 become 49 value. Decrement means in decrement the value by 1. Next is compare with the 51. The 51, what is the value stored? 48. 48 and 49 are equal? No, false, right? Okay. If it is equal, go to 505. No, it will not equal, right? It will not equal. See, immediate value accumulator 49. 49 with the 40 not equal. Jump only if it is not jump. Next, what are the next instructions? Jump 501. 501 means what is the value here? Accumulator value in the 501. 49, right? We'll go to the 49. What is the updated value accumulator is for 49. You can remain 49 and store to 50. Yeah, what is the value? 1 second. Jump back to the loop back to the 501. That is okay. Loop execution 501. Okay, now after the execution, loop decrement again. Control moves to 501. Jump back to the 501. 49 and 49 become what is the updated value become next again it is 48. Next 48 and 48. Correct. Because it is going to value of the this one become 48 and 48. Both are equal. Then jump if it is equal, it will directly go to the 505. 505 is 50. What is the value in the 50? Now you can store the updated value of 48 to the 50th register, right? That you are going to store. And what is the next instruction? Store, right? So next subtract 10. So your task is to 48 minus 10 is 38. Don't store in the 50 only. The accumulator only it will store 38. Next it is store to 51. What is the updated value that you can store in the 51? See, to know that if it is a subtract, add, that 10 value, increment, decrement, it should be in the accumulator. Only if it is a store, right? Then the value comes to the this way. Now, what is the value of 51 become? At the end, what is the 57? Store, after that, it is a 8. It is updated value is 38. Okay. Next question, what is the question is asked? Related. Complete the table by identifying and describe two mode of addressing that are not used in the party. That are not used. Here, what are the load he has used? Different types. LDM used, only LDM used. Other than LDM, what are there? We have LDD direct, indexed, and indirect, indexed, and relative. Actually, it is known as relative only. Okay. That value you can store. What is that? He has given direct addressing, the direct value, indirect, and indexed. Other than what is the question he asked? Other than this one, other than immediate, that another two you can write. He has given 3, you need 2. So don't confuse. Here, the one instruction he has added is, again it will go to the jump to the 51, 49 become 48. So that what is the purpose of this one? It is going to check. That is a loop. Now if it is equal, then it will come to the this one. So in the different question paper, different type of instruction you may give. Your task is to read the question properly and do it. Okay. Next session, I will do the another topic related to this one only. What is that? Another submerged question and related accumulator left shift, right. Sorry, not left shift, right. Sorry, logical shift, right. And accumulator. And the next related to the DBMS, database management system, the queries, how to write the queries, DDL, DML. I will create another one video. I will do that. Okay. Now, based on this, so many another question paper there. You go through it. If you have any doubts, please send me the mail, or else the comment. You can share your feedback. I hope it will be useful, and it look like a tricky. Once you practice, it will be easy. It is not a assembly is like a see. Now what you are doing in the software engineer programming, Python, Java, and all, that is high level. Computer can understand only binary machine level, right? 0 and 1. This is the assembly level. That is also low level. So we are dealing with the instructions. LDD, LDA, store, accumulator, all these things are comes in the assembly level language. That is inside the computer hardware. You must know that. That's what they are given the topic inside the ALAS level. So daily you can run 4 to 5 marks. At the end you will get it, and we can discuss the pseudo code and algorithm also. I'll create some video. You go through it properly. I hope it will be useful. Thank you.